Hello, thank you for joining us for the Solid Edge 2020 Lunch and Learn session. This is the first session that will, in a series that will take a look at some of the new features of Solid Edge 2020. Well, let's get started. First, let's take a look at if you're new to go to webinar, there's a panel that comes up on the right-hand side. And a few things you should know about it. You can shrink the control panel. There's a yellow, orangey colored button there that can shrink that. There's also a section down here to type questions in. We encourage you to ask questions. Well, there's a Q&A session at the end, but it's kind of nice to have some questions to go through, and saves a little bit of time. So pay attention to that. This model we're going to be working on and off, is from a company called WashTech that does bottle washing systems. They've been kind enough to lend us the entire model. This is a pretty beefy model with a lot of interesting components to it, and we'll be using this throughout the series. One thing I should point out, that the Solid Edge portfolio is growing from release to release to release, and Solid Edge 2020 is no different. This is pretty substantial. Some of my favorites here, you can see this list going from left to right. Some of my favorites here are the new model-based definition, and the MBD, which utilizes PMI data inside of your models and the ability to generate PDFs to share with suppliers. They continue to improve the Solid Edge electrical add-ons, simulation. This is exciting. They're now including some kinematic analysis software. This is above and beyond what Simply Motion was from Dynamic Designer. This is the full motion analysis tool that's included with Solid Edge Premium. There's some nesting for 2D nesting to output your models, let's say, to a CNC router or plasma table. Got those. That's an add-on to Solid Edge. And there's more in technical publications, data management, and even some of the cloud collaboration. I'll show you a little bit of the cloud collaboration here in just a second. So the big ones, these are the big, the heavy hitters, the top 5 of Solid Edge 2020. One of them is Augmented Reality. They've got a clever way of imposing your 3D models in an augmented reality manner, and I'll show you how that works in just a second. There's the model-based definition stuff, the MBD. Reverse engineering, we have a complete session just on reverse engineering, which is very interesting. There's the design for additive manufacturing. That's a DFAM. One example is if you have a tapped hole defined in Solid Edge and you want to just switch that to a threaded hole for printing purposes, there's a single click to do that. And today's topic is some of the core CAD enhancements. So let's look at the augmented reality piece. And what this is it starts at the Solid Edge portal. And the Solid Edge portal is an environment. It's a free website you can go to, and you can upload virtually any model from any system, any CAD system you want. And here's an example of what it looks like. Here's an iPad or an Android or an iPhone using the viewer, but it can show your solid models through the lens of your device. It's pretty interesting. So here's the Solid Edge portal. You can have projects you can share, collaborate, markup, measure with customers or clients. And what happens is, here's an example of the portal. You can explode, put things back together. I just want to show you a quick peek of that. But one thing here is you can generate a QR code page. Now, if you set that QR page that's associated with a model on a table or on a wall or anywhere, as soon as the viewer, the free Solid Edge viewer, hits it, it puts that model in your screen. And if you move that page, it actually moves the model. For instance, here we have a juicer on the table in a break room. and someone comes up and moves the piece of paper, slides it around, it actually moves the model in that environment. And it's a live background, so you can see when he puts the coffee pot there, it shows up in the image. Kind of neat, but it's a way to show, let's say your manufacturing floor, you want to show where the machines are, how they fit. It can do that from a single QR code. So let's dive right in at some of the core CAD enhancements. Here's some of them in a nutshell. There's the large assembly performance, some new sheet metal capabilities, some stuff on sketching and comparing 3D models. Let's take a look at some of the sheet metal first. There is lofted flange. Something that's really different in the lofted flange are the bend lines that can show up. You can really control how many bend lines you get. Not only that, but those bend lines can be actual real bends. Real bends meaning it bends the transition, and you can use vertex mapping with that. I'll show you in just a second. There's also some assembly stuff that we'll take a look at. So let's look at sheet metal first. Here we're lofting from a rectangular shape to an arc. And typically what we've had in Solid Edge is it makes these bend lines here. And these bend lines are what would be output in a DXF file. But now what we can do is, and this is what you'd get, by the way, a bend table with only 2 bends. But now what we can get are those transitional lines can actually be bend elements. And the bend elements will give you a very explicit bend table that you can use for manufacturing purposes. So I'll jump here into Solid Edge, and we'll start in with with a lofted flange. When I enter the lofted flange command, looking at the options, we'll see under bend method, you can turn triangulation to develop, and you have a lot of control over these. But the new one here is to make actual bends. So I'll answer OK. I'll select the first profile, select the second profile, and before I decide on a direction, I have another option here where I can do vertex mapping. You may have done this with solid models before or lofting, but here in sheet metal now we can add a vertex map. Let's say from here to here, and I'll answer OK. I'll put the arrow the direction I want and hit finish, and this generates an actual bend transition. You can see some of these here in this shows up on our model. We can actually go into tools. Let's make a flattened. We'll do a flat pattern. We'll go from this profile here to here and generate a flat pattern. Once a flat pattern is done, I can save this in my model, and what we can do is we can use this later when we're doing a blueprint. Let's go back to this here. Let's look at tools, and we have a bend table. We can now look in our bend table here, and we can see each of these bends. They're all numbered. And if I were to make a blueprint from here, let's just go to File, New, and create a drawing of the active model. I'll answer OK. And as I position my views here, one of the choices I can do is ask for the flat pattern, because that is stored inside the model. And when I have the flat pattern in here, I can then do the bend table like I did a moment ago. And as I select this, you can select one of your configurations, and you can see we have the bend table. It is identifying each of the bends and creates a table for these. So let's move back to presentation. All right, there we go. So another change that they've added is the bend bulge relief. Bend bulge relief, here's an example of a part where, actually I can show you a live part here in Solid Edge. we'll look at this. You can see, especially this is more noticeable on thicker parts. When you get right here at the corner, and the material would typically bulge out. When it bulges out, that would cause interference in where this is going to fit into a slot or against some other part. So they've given us a provision here to handle the bulge relief. So we can look here under bulges, under bend. We have the bulge bend relief, and I can select either this one end of the part, the other end of the part, or both of them at the same time, and it creates a relief right at the bend. Now those are rather small, so if I go in here and select the smallest possible relief, and that takes the least amount of material out of there, it actually does that and relieves the corner. And what's cool about this is you can then see on the flat pattern, when we update this, we'll go to the flat pattern, and the flat pattern shows that relief right there. So that's the bulge relief. Let's move ahead. And actually that bulge relief, by the way, there are options on that. You can control whether this is rounded or U-shaped, circular, V-shaped, etc. And these were the steps where you pick the edge that you want. You can actually pick multiple bends at the same time and give each of them an appropriate bend relief. This is new. This is a day-to-day time saver. If you've ever imported geometry from, let's say, a AutoCAD file or DXF or from some other system, or even if you had made a sketch and the sketch was completely out of scale, there's now a way to just auto scale the entire sketch in Solid Edge. It's a simple switch that you turn on. It comes on by default. It's right here in the draw toolbar that is depressed. And what it does, it works like this. Go into a sketch we might have, and I'll take this sketch. This is very basic, just basic geometry, but I'll select this and edit this sketch. And we can take any dimension. This is a driving dimension. Notice it's red compared to all the other blue ones. And I'll change that from 2 inches, let's say, to, or 2 point whatever it is, to 1 inch. And in doing that, it very quickly scales the whole rest of the sketch uniformly. You can have that do just by simply unticking this icon here, auto scale sketch. You can independently do it just like you're used to. But I think that's that'd probably a time saver rather than trying to calculate the number of the scale amount that you'd have to do. So let's close down some of these. Got a lot of things open here. I'll close a couple of these out. All right, so now here, and let's go back to the PowerPoint. All right. They've actually done a number of performance improvements. One of them is in 2D. Again, like the opening in a DXF or DWG file in 2D, many times I've seen where these are just massive drawings. You got lines on top of lines on top of lines. Here's an example on the left that shows 112,000 objects. And we can simplify the sketch, sketch command that can siphon this down to 36,000 objects, making it much more nimble and usable on your system. They've done some improvements in speed for large assemblies as well. And there's a single check mark here in options. By checking this and answering how many parts in your assembly you want the large assembly performance mode to kick in, you just type in the number there. This one's set to 5,000. I set mine to, I think, 1,000. I'll show you in just a second. And it goes through the entire system and shuts off everything that would impede performance while still letting you work on your model. And it's not global in that it's not going to stick your entire system with all of these settings for your entire session or permanently. It does it on the fly per model. I'll show you what I mean by that. If we'll close out a couple more of these, I think give some miscellaneous files. So this is typical. We have this highly rendered assembly, and it can be activated, can have a bunch of texture settings turned on. Notice at the bottom there is a shadow, floor shadow, and there's not that many pieces in this assembly, but if this were a large assembly, that would certainly slow it down. So let's open this assembly. This one's much larger. That's that entire product that showed at the very beginning. There's lots of parts in it. Actually, we can count the parts. Selecting inspect, and we'll do the geometry inspector, excuse me, we'll do the assembly statistics. Geometry inspector is also another cool tool I hope you're using. The total parts in this is 1,712. So by my setting the my options in here under settings options, I set my assembly size for I think it was 1,000 parts, 1,000, use large assembly performance, and that lets me work on this model much faster. I can spin this around. If I look under view, you'll see the floor shadow is off, the floor reflection is off, view overrides. It went through and shut off a bunch of these settings, and it did not do that for the other assembly that I had open. This is back to having the high quality. So that's a real handy tool where you don't have to worry about messing with too many settings. You just set it and forget it. So let's continue on here, and let's see. These are some of the validation data on the before and after, and this is a very large assembly here where it had a setting of very slow, a 1.7 hertz reactive screen action compared to 3.7 hertz. There's some movies in here. I'm not going to run these right now, but this was a substantial increase in performance by 217%. This is another little gotcha that you may have run into before in assembly, where you're working with patterns, and it's a small thing, but it's worth mentioning. If you did this little assembly here, I have say I do a pattern, I select my part to pattern, I right mouse button, I select a part that contains a pattern, I select the pattern, and then I select one of the instances, and the pattern goes the wrong way. This would happen in the past if you had a fast pattern or a synchronous part containing a pattern, but we now have the ability to select this. I can then edit the pattern in a subtle button right here, which is pattern reference position. I can pick my first reference position, hit finish, and it fixes the pattern and puts it back. That's a pretty good time saver, I think, rather than having to redo your pattern from scratch. Returning here, this is something new. It's called compare models. Compare models. We've had compare drawings for a little while. This is right where you go to your settings for options. With no files open, you can go to tools, select compare models or compare drawings, and you can compare the volumetric data from one model to another and get some visual feedback. You can even create a report. I'll take a look at that here in Solid Edge. We'll go to the tools, compare models, and let's select our first model here. We'll just browse for it, and first model might be, we'll call that body 1, and let's come back here and hit open, and then we'll browse over to body number 2, select that. And these are independent models. You can see these as I spin them around. We can line them up. We have align models here. I'll select this right here. So they're both aligned, and then we'll do a compare, and it will run the analysis between the two, and we get some color code that gives us a idea of what's going on here. Anything that is green is common to both models. If you see red color, that's added material from one to another. And we can go through and look at this analysis. It's actually, you can see it in more detail. There's a generate report button, and that generates an HTML report. And the HTML report here, here's an example of it that breaks it down with a bunch of data and some images on how the models compare. So that's about it for this first cursory look at Solid Edge 2020. I didn't see too many questions. I saw one question in the list that was asking about when Solid Edge 2020 is being released. And one place I look here is in the support.ugs.com or the GTAC site under full products for Solid Edge. They'll make a folder there that will say Solid Edge 2020 to download, but you will be getting a notification from us. Be sure to continue and watch some of the ongoing sessions. That's all we have for today. I thank you for your time.